So I'm here to teach you guys balancing equations for chemistry. Let's get this started. This is the new unit you guys will be learning for chemistry. It's called balancing chemical equations. It would be very helpful for you guys to copy down the notes I will be saying in this video. So here you go. So balancing equations. So first of all, you need to learn about chemical equations. So it's what describes what a chemical reaction is. There are reactants and there's products in the formula. Reactants are the starting material while products is the ending substance. For example, right here, you see N2 plus H2 is arrow and H3. So this first part right here is the reactants. This is what is the starting material is. And then this is a product, the ending material, which is the resulting. So the arrow, it shows what direction of the reaction it is. So obviously it's going to the right, so the reaction is to the right side. So you also need to know about coefficients when doing balancing equations. So coefficients is a number in front of a compound. Again, here's an example. CH4 plus 2O2, arrow, right arrow, to CO2 plus 2H2O. So the first two numbers are the coefficients. It's the number in front of the compound. So even if the compound number is empty, it's always gonna be 1, because 1 is just a constant number for the compound. So our main objective is to balance non-balanced equations to make number of atoms equal to reactants and products by placing numbers in the coefficients. So important factors you need to consider when balancing equations is, first, coefficients have to be whole numbers, not fractions or mixed numbers. You cannot do that when you're balancing equations. Second, you cannot change a compound in any way. So this example, Al plus O2 and Al2O3. You can't put 1.5. That's not a whole number. So error. That doesn't work. And then you would think you can just change this to AlO2 to match this, the reactants. But again, you cannot do that. These are two important factors you need to know before you're balancing equations. Given the equation, you must identify these 4 things. What compounds are unbalanced? What is the highest atom number for the compound? Multiples of the number that will work for the reactant and product side to be equal. And once you're finished with the balancing equation, if it's the lowest possible factor available. Start balancing some equations. So with the 4 rules that I gave you, what compounds are unbalanced? Obviously the Al, the O2, they're obviously not unbalanced with those products. And what is the highest atom number for the compound? Which is 3 for oxygen. And multiples for the number that will work for the reactant and product. So 2 is for this reactant and 3 is for that product. So the closest multiple that will work is 6. Because 2 times 3 equals 6, 3 times 2 equals 6, obviously. And and the last step is if it's the lowest possible factor, but we haven't even started yet. So first of all, Al, we'll start with the O. So again, I said 2 times 3 equals 6. So here you would do 2, because 2 times 3, that would be 6 for O. And then, well, what equals 6 here? That would be 3. So here, 3 times 2 equals 6. So the O is balanced. So now for Al, so since we put 2 in the front, for the O, we have to do 2 times 2. So that's 4. So it would be A L4. So, and here our atom is only 1 because that's a constant and we don't have anything there. So what's a number that can equal 4 with using 1? Obviously 4. 4 times 1 equals 4. You put a 4 there. And then you're balanced. And you check for the lowest possible factor. 4, 3, 2. You can't divide that by just one number to make it smaller. So that's it. That's all you need, and your equation is balanced for example 1. On to example 2. H2 plus O2 is equal to H2O. So we need to balance this equation. So H2 and H2 is already balanced, but O and O2 here is not balanced. So to make O balance with this, you would need to times by 2, because again the atom is 1, so you would need to add a 2 to the molecule. So 2 times O, which is 1, again that's 2. So O2, so O2 is now balanced with this, but since you multiply by 2, you have to do it for oxygen as well. So that'll be H4. Now this H is not balanced with this. So what's 2 times blank equals 4? Obviously that's 2, so you would add a 2 in the front. And this O2 is balanced with that, so you just add a 1, which is a constant. You don't need to add the 1, it's just there, just to help you. So again, 2, 1, 2. Is that the lowest possible factor? Yes, because you can't divide this one by 2. You can only divide them by 1, which is still the same number. So example 2 done, it's balanced. Example 3. This is a pretty difficult one for you guys, but okay. H8. So that's the highest possible atom in this whole equation. So you're trying to get H2 to equal H8. Again, 2 times blank equals 8. What can that blank be? Obviously, it would be 4. So you would add a 4 there. So now it would be H8, because 4 times 2. And then you have to times 4 by the O, so it would be O4. So now you need to get O2 equal to O4 and O2, because O2 is and O4 is here, so you add them together, the amount of atoms. So O4 and O2, that's O6, like that's 6 atoms altogether. And then this is 2 atoms altogether for O. And then on here you see the C3, and then this is only C, and this is the only C in the product. So that's easy. What's 1 times blank equals 3? So you just put 3. So you put 3 in this equation. So C3, you get to C3. C is 1, so 3 times 1 is 3. And then, but you have to multiply 3 by the O2, so it'd be O6. So now you have O6 here and O4 there. So O6 plus O4, so 6 plus 4 equals O10. So now you need 10 here, and you have 2. So what's 2 times blank equal 10? What number can that be? Only one number, 5. So you would put 5 here. And since this is already the highest amount of atoms, and all this product you're trying to equal to this, you just keep it 1, it's constant, because you don't need to do anything with it. So that's how you do example 3. Here, I'm going to try to trick you guys with this problem. I shall balance it right now. So O3, and there's O2, so you're trying to balance those. Okay, so 4 here, because with the multiples, it would go to 12. So 4 times 3, that equals 12. And then what's to get to 12 here? 2 times blank equals 12. So that would be the only number 6. So you put 6 there. So you got the O2, the O's balanced. So now you need the KCl balance. So this would be K4 now. That would be Cl4 because 1 times 4. So it would be, here, I'll show you, C4O12. So that would be the equation. This one would be O12. So we need a K4Cl4. Obviously, this is 1, so you need 1 times blank equals 4. That'd be 4. So you put 4 on top. So there's balanced. Do you see anything wrong?
No.
Well, there's a problem here. Even if it's balanced, it's not the lowest possible factor. So 4, 4, and 6, it can all be divided by 2. So divide by 2, that would equals 2. Divide by 2, that would equal 2. Divide by 2, that would equal 3. So this is the lowest possible factor, and that's how you do example 4. A real life example of balancing equation. So we got 1 blue shoe in the reactant, 1 red shoe in the reactant, 1 blue shoe in the product, and 2 red shoes in the product. So 2 red shoes in the product and 1 red shoe in the reactant. What do we have to do? We have to balance them and make them equal. So 1 red shoe in the reactant with 2 red shoes in the product. You need 1 times 2, which is add another shoe. Here, we add another shoe. So now we got 2 red shoes reactant and 1 blue shoe in the reactant, 1 blue shoe in the product, and 2 red shoes in the product. Now it's balanced, as you can see right here. It's balanced. Thank you. I hope you liked my video. If you enjoyed my video, I hope this made you learn something about balancing equations. Thank you for watching. I'll see you later.